Problem number 4. So we're back to the original function, f of x equals x cubed minus 4x. Let's put that in the calculator. So I'll go to the y1 area and put back in that x cubed minus 4x. And now we're going to make another new function called g of x, and this new function is f of 2x. So this time, instead of multiplying a number on the outside, I'm multiplying a number on the inside. So how do I work that out? Well, f of 2x just means replace every x that I see with a 2x. So this x, and this x. F of 2x would be 2x cubed, and then minus 4 times 2x. So I've replaced all the x's with 2x's. And then I could simplify this, but the directions are telling me not to worry about it. I'm really just interested in what happens with the graph when I make this kind of change. So I'm just going to go to the calculator and type this in on the y2 line, and then we'll see if we can figure out what happened. So on the y2 line, I'll use parentheses. I had 2x all being cubed, and then it was minus 4, and then parentheses 2x. The calculator doesn't care whether we simplify it or not. I'll hit that graph button. This new one will come up in red. The original one is the one in blue. Okay, so what happened this time? Well, some sort of stretch or compress, I think. Let's see, if I start with the blue one, it looks like somebody from the left and from the right have pushed it in toward the y-axis, right? This hill here has been squished in from the side, and the valley has been squished in. So we'll say it's been horizontally compressed. Let's see, how much did it compress by? Focus on the x-intercepts. It looks like this one was at 2, and now it's at 1. This one was at -2, and now it's at -1. So it looks to me like the x values have all been cut in half, which is why the graph squished in. So we are saying it compressed horizontally this time by a factor of 1/2. Notice that this is a little bit more complicated than the outside multiplications. When we multiplied by the 2 on the inside, maybe you thought that was going to make a stretch, but instead it compressed and the x values were cut in half. Okay, part D, one more new function. Now I have h of x equals f of 1/3 x. And so I'm doing the same thing. I'm replacing all the x's with 1/3 x. It's going to be just the same thing we did before. Every x there gets replaced with a little 1/3 x. And once again, I could simplify, but I'm not going to worry about that. I just want to get that into the calculator and compare. So I'll go back to the y equals. Let me remove this equation and put in our new equation. We had in parentheses 1/3 x. And that's all being cubed. And then we had minus 4 and in parentheses 1/3 x. So we're trying to figure out what happens if I make one of these inside multiplications by a fraction. I'll hit the graph, blue graph original, here's the red graph. Okay, this time it looks like someone has grabbed the blue function from both sides and stretched it out sideways, either to the right here or to the left. It's gotten a lot wider than it was before. How much has it been stretched out? Again, look at the x-intercepts. I used to have one at 2. If you count out, I think it's at 6 now. And the one that was at -2 is out at -6. That's 3 times as much that this thing has been stretched out horizontally. So we're saying stretched horizontally by a factor of 3. Notice again kind of the reversal. The fraction might have made you think compression, but when it's an inside change, it's actually a stretch, and instead of all the x's being divided by 3, they were actually multiplied by 3. Okay, let's put this together now in number 5. We've got a function called p of x. We're going to make a change to it. We want to write an equation now in terms of p of x. So something like we had here. Okay, the first example, r of x is formed by horizontally compressing p of x by a factor of 1/4. Now, the one that was the horizontal compression is the one that was up here, and the way we got a compression of 1/2 was by having an inside multiplier of 2. In other words, by using the reciprocal. So if I want to have a compression by 1/4, a horizontal compression, I'll have to use an inside multiplier of 4, the reciprocal. This would be P of 4x. That would be the answer. Second example, T of x is a horizontal stretch by a factor of 12. Well, that's like the second example from number 4. A horizontal stretch, that's the one where I have to use a fraction on the inside. How will I do that? It will simply be the reciprocal of the factor. So if you want to stretch by a factor of 12, you're going to have to do P of 1/12 x. So these horizontal changes are a little bit trickier.